because I extended my desktop. So it doesn't know, it records that one, even though I tell it not to. Okay, so we got toboggan racing down a hill. So we have this. Probably not that steep, but it's a hill. Okay, and the toboggan is going down the hill. Okay, up here at the start of the hill. Okay, it is 30 meters above ground level, and it is moving at 14 meters per second. Okay, and then a little while later, it is moving at 23 meters per second. So that would be further down the hill. We're looking for its final height. Hey, everybody with me there? Okay, work energy theorem or conservation of energy? Conservation of energy. There's no force, there's no distance, there's no mention of work. Okay, so EI equals EF. And in this question, we have kinetic energy initial, potential energy initial, kinetic energy final, and more than likely HF is not zero, so okay, probably some potential energy final as well, since they're asking us to calculate the height. All right, so that's going to be EP initial plus EK initial equals EP final plus EK final, and what I'm looking for is part of this. So I want to subtract EK final over to the other side before I plug in the formulas. Okay, now I'm going to plug in the formulas, so I'm going to have M times G times H initial plus 1/2 MV initial squared minus 1/2 MV final squared equals M times G times H final. M is in every term, so I'm going to cancel it, okay, and I'm going to divide by G to get HF by itself, and then I'm simply going to plug in my numbers. So 9.81 times 30 plus 1/2 times 14 squared minus 1/2 times 23 squared divided by 9.81. All right, so now it's only 13 meters above the ground. Any questions on that one? Okay, so.
Would we also be able to write initial energy equals final energy as mechanical energy equals total kinetic energy plus total potential energy?
That's what I wrote, yeah. So definitely, that's worth a mark, yeah, right? Because what I'm saying here is, yes, this is mechanical energy, this is mechanical energy here, okay? This is how I calculate mechanical energy. I add this and this, that equals this and this. Yeah, so exactly what you said, yeah. All right. Okay, so on your unit exam, which we're going to do the unit exam tomorrow, or unit exam review tomorrow, not the unit exam tomorrow. Oh, everybody's eyes got a big there, sorry. On your unit exam, there will be a question very much like this, okay? I'm either going to ask you to calculate a height, or I'm going to ask you to calculate a speed. Okay, just like the question on your quiz this morning, you had to calculate a speed. Okay, on this one you had to calculate a height. It's all patterned, right? As long as you can identify it as a conservation of energy question from a work energy theorem question, it's just follow the pattern, right? And then do your algebra and solve, right? What I'm seeing, looking at people's quizzes, that people get this, they seem to understand it. I mean, it's mostly math. So if you're pretty good at math and algebra, this probably just comes pretty naturally to you. But I also want you to understand the science behind it. Being able to solve the problem, if you're good at math, that's nice. But I also want you to understand what's going on in these problems, right? In a problem like this, we have a certain amount of energy at one point, and we have that same amount of energy later. Okay? Mathematically, that's EI equals EF. But we have to understand that what it means is energy can't be created and it can't be destroyed. If I want something to go faster, I've got to convert some form of energy into kinetic in order to get more kinetic. Okay, in this case, we're converting potential into kinetic, because as we go down the hill, we have less potential, more kinetic, that's why we go faster. It's that understanding that's gonna get tested in the multiple choice. Okay, there'll be kind of questions like that that aren't math-based, but check whether you get the concept or not. Okay, the written response will have the math-based understanding stuff, because both are important. Okay, making sense to everybody? All right, what do we got left here? About 20 minutes, right? About 15 minutes. Okay. I'm going to put another one of these up on the board. It's going to be just a little bit different. And then I think we're good with this, which makes me feel pretty good. Like looking at people's quiz scores this morning, it looks like people get this, so that's good. Monday, we'll do efficiency, okay, which is the last thing in this unit. Okay, and then I'll probably throw a few kind of practice questions your way from all parts of the unit, kind of seeing how we're doing with that. Because Friday, we won't get much time to practice for the test. We'll basically just do the review part. And then Tuesday's your test. Okay, so it's coming right up. And then Wednesday, we'll go over the test, and we'll start Unit 4. And then Thursday, we'll continue on with Unit 4. And when we come back, we'll finish Unit 4 end of that first week.
Do we have school on Thursday?
Yes, we definitely have school on Thursday. I agree with you. I don't think we should, but we do. I don't think we should have school next week, but I don't make those decisions. It's above my
Monday
pay.
was the 20th.
No, no. That would be bad, because then your test will be Monday. Yeah. Okay, so yeah, we'll finish up that unit Friday of that first week back after Christmas. We'll have the unit exam probably the following Monday. And then we'll go over that unit exam and have 2-3 days to review for our final exam. Okay, probably something like that. At worst case scenario, we'll have the unit exam on the last Tuesday. Okay, but that last unit is pretty short, so we'll be able to get through it pretty quickly. Right, Adam?
Yeah.
Okay, so this one's just a little bit different. Actually, a little less math than the last one. Okay. All right, so we've got our cliff and our car. We're going to drive off the cliff. Don't ask me why. Doesn't seem like a good idea. Okay, 25 meters per second, and we are looking for the height of the cliff. That would be our initial height. We don't know what that is. This would be our initial speed. Okay, the cart is obviously going to go all the way to the ground. And there'll be like flames and stuff, and that'll be all bad. Okay, so down here, what's our final height? 0. All right, and our final speed is 53 meters per second. All right, since we know all of that stuff, okay, this is going to be an EI equals EF, law of conservation of energy question. Okay, when I'm setting it up, I've got initial kinetic, I've got initial potential, final potential, final kinetic. Which one of these is 0? Final potential energy is 0 because the car crashes into the ground where the height will be 0. Okay, so we don't have any final potential energy, which makes our manipulation a little simpler because we don't have to move that over to the other side now, it's gone. Right, so now we can go 1/2 mvi squared plus mghi equals mghf. Okay, whoops, sorry, I screwed that up. No, we do have to do a manipulation. Okay, I'm going to have to solve for EP initial, so I do have to subtract this over to the other side. Sorry, I got carried away. So I got EP initial equals EK final minus EK initial, right? And then we can go M times G times H initial equals 1/2 MV final squared minus 1/2 MV initial squared. Okay, the M's will cancel as they always do. Okay, divide both sides by G. And now we're solving for HI. Okay, so we'll have in our calculators, okay, 1/2 times be at 53 squared minus 1/2 times 25 squared divided by 9.81. Okay, so our initial height is 111 meters. That is a tall cliff. Okay, now, guys, in a question like this, here's where people go wrong. So check, if you didn't get 111 meters, check where you went wrong. Okay, people sometimes square root when they don't have to. Okay, in this case, I didn't need to square root my answer because h isn't squared. Second thing people forget, they forget to square these two numbers. Okay, in the calculator. That also affects the answer. So just little details. If you're finding, man, I'm doing all the work right, I have everything on my paper the way Codere wrote it, but I don't get that answer in my calculator, it's probably one of those two things. Okay, it means you know how to do the algebra, you're just not good at punching it into your calculator yet. Okay, and you will get that. Okay, you'll get better at it. All right, so tomorrow, unit exam review. Come ready for that.